Today, we'll be demonstrating modern privileged identity management with Signal, which enables protection of your critical systems in real time. In this demo, I'm going to show you how Signal secures cloud infrastructure by protecting against damage from excessive standing access granted by identity providers like Okta. With more than 80% of organizations having suffered an identity-related breach in the last 12 months, it's clear that existing security controls are not adequately protecting enterprises from breaches, and identities are the prime target for threat actors. Today, many organizations use single sign-on as a secure entry portal into applications and services. While identity providers are great at verifying a user's identity, without data from a company's range of SaaS applications such as CRM and HRIS services, they lack the capability to make authorization decisions based on dynamic business justification. When these identity providers are then used to authenticate high-value, high-risk sign-in events, users are often permitted access to sensitive data with limited restrictions. Once attackers have bypassed SSO defenses, they can proceed to infiltrate a number of critical systems, gain access to sensitive resources such as databases, virtual machines, and more. Take a fictitious company called Wholesale Chips, for instance. Wholesale Chips uses Okta, an identity provider, to federate their employees' access to AWS, where they can store sensitive data, virtual machines, and more. Without Signal, users can access AWS through Okta as long as their long-standing attributes comply with simple policies. However, if a user without proper business justification accesses AWS, such data and resources are put at serious risk. For instance, in 2019, an AWS data breach involving employee credentials impacted over 100 million customers, exposing sensitive personal information like social security numbers and bank account numbers. Wholesale Chips is a prime example of an organization that can enhance their authorization through Signal. With Signal, they're able to grant dynamic access to AWS by validating that access using data from systems of record like Okta and ServiceNow to determine if the right user is requesting access at the right time, then immediately revoking access when context changes, achieving zero standing privilege. Let's go back to examine a specific scenario where Wholesale Chips does not have Signal. Wholesale Chips has designated a role-based access permission in Okta, specifying that all engineers are granted full admin access to AWS for use in emergency situations. Alex, an employee in the engineering team, is therefore allowed to federate to AWS using Okta at any time. Without Signal, Alex is given access to the entire AWS environment, allowing him to access and manipulate sensitive information that may be beyond what he needs to solve the problem. Using Okta's Apps dashboard, which has integrated sign-on to AWS through Okta's single sign-on service, Alex will now attempt to access AWS. As you can see here, Okta signs him into the AWS Management Console, giving Alex unfettered access to other data and virtual machines, as well as users, roles, policies, and permissions. But should Alex have this heightened level of access in AWS, which allows him to create new AWS users or view sensitive data stored in the cloud? We'd like to introduce you to the Signal platform, which helps organizations answer that question. Here is the Signal dashboard for Wholesale Chips, which integrates with systems of record to unify critical business context that is applied to policies to inform real-time access. Let's delve deeper into the systems of record that are synchronizing data into Signal to support policy decisions. Similar to numerous organizations, Wholesale Chips makes extensive use of third-party SaaS applications to manage their engineering team, customer service, employee directory, and human resources. They've integrated their applications as systems of record into Signal, syncing business context from Entra ID, Okta, and ServiceNow, which is their IT service management platform. Now, let's see how those systems of record can help protect your critical systems in Signal, which we call protected systems. Signal can enable conditional access for your cloud infrastructure, code pipelines, and customer data. In this demo, we'll focus on the AWS use case. To protect AWS, Signal has integrated with Okta to add authorization layers into Okta sign-in flows for access to AWS. We do that through transforms, which leverages inline hooks to allow Signal to be involved in the decision-making process for the roles and permissions granted to a user in the process of federation to AWS. Now, with our systems of record and protected systems in place, let's look at how we can configure policies in Signal to restrict access to AWS to users with significant business justification. Going to the policies here attached to AWS, we can see that engineering users can access production assets if they have an active emergency change assigned. Taking a closer look at what this condition means, we can see that access to production assets is restricted to users who have an active, approved emergency ServiceNow change assigned to them. With this new policy defined, Alex will need to be working on a task or incident that gives him business justification if he wants to access AWS production assets. Now with these new Signal policies in place, let's give signing in to AWS through Okta another go. Since Alex has not yet been assigned the relevant ServiceNow change yet, we'd expect that he is denied access to AWS. As you can see here, Signal has successfully configured AWS permissions to deny access for a user who did not have business justification to sign in. With that, let's come over to ServiceNow here and assign Alex the change that he needs to access AWS. We can see that this change here is an active change with a type set to emergency, and that it's a high priority, high risk item. Let's go ahead and assign Alex to this change, and then we'll also go ahead and approve this change for Alex as an administrator. Alex now meets the criteria that we've defined in our Signal policy for emergency access to AWS. With this ServiceNow change in place, jumping back over to the Okta's apps dashboard, let's give Alex sign-in attempt another go. We can see that Alex is now able to access AWS as he has the business justification to do so. He can click around and access different resources he needs to address the ServiceNow change. Now, even though Alex was compliant with policy when he signed into AWS according to our Signal policies, things could change. By default, AWS sessions are 8 hours long, which is short compared to many systems that maintain sessions for days or even weeks without checking if access is still valid. But what happens if Alex completes his work in AWS and the emergency incident is closed before that time is up? In many situations, Alex would retain access to AWS even when he no longer has the business justification to do so. But with Signal, we can continuously listen for those changes around business context and determine when Alex's access should be modified. To demonstrate this, let's go into ServiceNow and let's say that we no longer need Alex to work on this emergency incident. So we can come in here and cancel the change, say no longer needed. We can do other things like mark it as low priority. Since we defined that an active emergency change is needed to grant users access to AWS, Alex is no longer compliant with our policy. Signal will notice this and revoke Alex's access to AWS. We can see this as clicking around in AWS, we'll see that Alex's access has been revoked in real time. We can see the access removed all over AWS. Signal can also notify the security operations teams when actions like session revocation occur. Going into Slack here, we can see that Signal has also sent a notification about Alex's AWS session being revoked. Thus, Signal has continuously granted and revoked access for Alex to AWS, eliminating standing access. We can take a quick look at how this works inside of Signal. In our Continuous Access and Evaluation Hub, or KPUB, we can see that some actions have fired here. Specifically for Alex, the revoke AWS session and notify trigger was set off, which, if we look at what this looks like, we've defined here as the closure of the emergency access requests. Just as we saw with Alex, this then resulted in the two actions, the AWS revoke session and the Slack notification being sent out for access being removed. Thus, leveraging CAPE protocols, Signal can, in real time, eliminate user permissions from live sessions or future sessions of a user in response to a detected identity threat. Since Signal synchronizes access management across protected systems, Signal makes auditing access easy with information from all applications in a centralized platform. For debugging or auditing support, we can also view a log in the policy lens to see why a specific access decision was made in regards to the policy snippets involved. Going back into the logs in the KPUB section and going into the actions completed, we can see that in-session access for Alex's AWS session was revoked after we canceled the ServiceNow change. As you've seen through this demo, Signal helps organizations eliminate standing access by granting dynamic access based on contextual business needs and then revokes that access when context changes. Today, we demoed a specific example of Signal's cloud infrastructure use case with Okta and AWS integrations. To learn more about Signal and other use cases like protecting code or live user sessions through context-based, CAPE-informed policies, visit signal.ai.